location measures. Let's start with the mean, with arithmetic mean. Okay. Arithmetic mean. Here measures of location. Sometimes it's called central tendency measures. Central tendency measures. This is a number. Number can give an idea about a set of data. Okay, let's start with arithmetic mean. What is arithmetic mean? Of course, it is used with interval or ratio scales measurement or numbers. Must I have numbers to get arithmetic mean? Okay. All data values are used in calculation. All my data are used in calculation. It's unique. Just for one set of data, there will be one arithmetic mean. It can't be two. Sum of deviations from the mean equals 0. This will see it through our examples in calculating the variance. I will show you how. A weakness. Okay, third, a weakness of the mean is that affected by extreme value. Weakness of arithmetic mean is affected by extreme values. Extreme values, either very large values. Okay. How to calculate the mean? How to calculate the mean? Mean is denoted by mu if it is dealing with the population, or by x bar if we are dealing with a sample. Either mu for dealing for a population, x bar if we're dealing with a sample. That's all the same. All the same. Same formula. Sum of all data divided by its number. Sum of all data divided by its number. This is for the mean, arithmetic mean. Let's take example. This data, set of data. I want to find the average value. The average value, I need to add 11 plus 4 plus 10 plus 4 plus 9. Add all this data and divide by its numbers, 42 numbers. 192 divided by 42 is 4.57. So this is the mean. Here it's mu. Why it is mu? Because this data, this 42 data is a population. Why it's population? Because there are 42 exits on I-75 through the state of Kentucky. Listed below are distance between exits. This covers all the area, all the state. All the state, there are 42 exits in all the states. So this is a population of exits in that state are 42. So this is a population. So it's considered as a population. It's population because we are considered all of exits in that state. Not a sample, it's covered all. The mean sum of this data divided by its number 42 is 4.53. Okay, it's very simple, I think. Sum of data by its number. This is the mean. What is the median? Median is a midpoint of values after they have been ordered from minimum to maximum. If I have a data, for example, this number of hours, a sample of 10 adults used Facebook last month. Okay, this is a sample for 10 persons, 3, 5, 7, 9, these 10 numbers. I want to find the median. Median for these values. If I ask you to find x bar, arithmetic mean, okay, you'll say 3 plus 5 plus 7 plus divide by 10. So this is x bar. This is the mean. I don't want mean, I want median. The median first thing I must order my data from minimum to maximum. I want to order my data. This is 1, then 3, then 3, is another 3, then 5, another 5. That's it. Then 7, another 7. No. Then 9. Then another 9, then 10, then 17. 1, 2, 3, 4. This step, arrange my data from smallest to largest. Disarrange my data from smallest to largest. Here, my data is odd number. This number 10 numbers. 10 are the even number. Number in the middle. That number 5. Because 10 divided by 2 is 5, or number 6. Okay. Number 5, this 1, 2, 3, 4. This number 5. I said number 5. I will count how many numbers here I have. 1, 2, 3, 4, 5. Before 1, 2, 3, 4. It's 4 numbers and 5 numbers, which is not accurate. So my data is even. So the number, these 2 numbers in the middle, 10 divided by 2, and number 10 divided by 2 plus 1. Take the average of these 2 numbers. The average of these 2 numbers. 10 divided by 2 is 5, number 5, and number 6. Take number 5 and number 6, the average of number 5 and number 6. Where is number 5? This is 1, 1, 2, 3, 4. This is 5, number 5, and this number 6 in order. So median in a median order equal number 5 and 6. What's the median as a value here? Median should equal 5 plus 7 divided by 2. Average of these 2 values, 5 plus 7, 12 divided by 2 is equal to 6. So median is 6. Okay, we'll take more examples. Let's add one number more. For example, 20. Add one number. This 11. This is even. This odd number. 11 odd number. So median order. Median order equal this 11. 11 can divide by 2. 11 can divide by 2. So 11 plus 1 divided by 2 is 12 divided by 2 is number 6. So number 6 is the median. So median equal, what is number 6? 1, 2, 3, 4, 5, 6. So number 7 here is the median. Median is number 7. If I have 11 numbers, not 10, 11 numbers, I add one number more. Okay. Characteristics of the median. The median is the value in the middle of set of ordered data. So it shouldn't be affected by extreme values. For example, if I say this, if it's number 20, I found it's become 7. If this number is 100, not 20, does it affect? No, it doesn't affect the value because the value depends on order. Value depends on order. Not depends on the value itself as an arithmetic mean. So median. Okay. at least the ordinal scale of measurement is required. And then ordinal scale it can be applicable to find the median. My data to be ordinal. It is not influenced by extreme values, not affected by extreme values. I said if it's here 200 or 200, it doesn't affect. It's 7. Whatever be the largest, the extreme number or small numbers. Yeah. 50% of the observations are larger than the median. It's unique for a set of data. For any set of data, there is only one median. Let's take the mode and we'll take more examples to cover all 3 measures. The mode, which is the most frequent value, the value of the observations that occurs most frequent value. Here, okay, this example, number of respondents favored various bath oil. I have about 120 persons. They said it's more. It is more than 350 customers. Soother, smell nice, fat, bar out. So the most frequent one is 300. This mode is called the mode. Mode can be found for nominal level of data. Set of data can have more than one mode. It could be also more than one mode. Okay, we'll take these examples later on. Just now I need to know what's the relation between median for a specific set of data. For any set of data, if I found mean, median, and mode, these 3 measures of location, 3 values. I found mean, median, and mode. If I found the 3 are equal, if the 3 are equal, it means my data is symmetric. My distribution is symmetric. In symmetric distribution. Mean equal median equal mode. Okay, if mean greater than median, always median in the middle. Always median becomes in the middle. Always median becomes in the middle. If mean greater than median, then mode should be less than median. If mean less than median, then mode greater than median. Median in the middle. If X bar greater than median, so I have positive skewed. My data is positive skewed, like this case, this positive skewed. If mean less than median, then my data is negative skewed. Okay, this question. The following is the number of daily report cases of 9 days. 5, 5, 5, 6, 6, 7, 8, 9, 12. What does the sample mean? Here. What does the sample mean? Arithmetic mean. What does the sample mean? I said for the sample mean, I add all data, add it together and divide by its number. I add 5 plus 5 plus 5 plus 6 plus and divide by 9. Divide by 9. Answer is 7. This is sample. So this is mean. What is the median? I need to find the number in the middle after arranging my data. from smallest to largest. Here is my data is arranged 5, 5, 5, 6, 6, 6, 7, 8, 9, 12. This is nine numbers. Okay, I arrange it. First step. Now I need to find median order. Median order. Where is the median? Where is the location of median? Is it here, 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 here? Here, how many numbers I have? 9. I said it's number in the middle. I said 9 divided by 2, just to memorize it. 9 divided by 2, it doesn't work. 9 can't divide by 2 without mean. So I add 9 plus 1 divided by 2, which is 10 divided by 2 is 5. 10 divided by 2 is 5. So the median is number 5, reading number 5. Where is reading number 5? This is 1, 2, 3, 4, 5. So median equal to 6. Median equal to 6. This is the median 6. What is the mode? What is the mode? Most frequent. I know it's here 5 is repeated 3 times, 6 2 times. So mode is 5. Mode is 5. It's repeated 3 times. Okay, what's the shape of distribution? I ask you a question in exam, what is the shape of distribution? I know mean, median, and mode. Now, look to the median. Look to the mean. Look to mean. Mean, 7. هذه X bar. Median is 6. So X bar is greater than median. When X bar greater than median, so my data is positive skewed. I write positive skewed. Mean greater than median. Okay, should be greater than what? Distribution is positive skewed. ليش? Why it is positive? Because mean greater than median. So it is positive. If mean less than median, it is negative skewed. Weighted mean. This example, how about this example? Carter Construction Company pays its hourly employees $16.5, $19, and $25 per hour. They have 3 rates, 3 average, 3 wages rate. They have 3 rates, rate $16.5, rate $19, rate $25. They have 26 employees, they paid 16.5. No, sorry, they have all, total is 26 employees. 14 are paid at 16.5. And 10 employers, they're paid at $19 rate, and 2 at $25 rate. What is the mean hour rate for the 26 employees? For the rate for 26 employees, I multiply this 14 times the rate plus 10 times the rate plus 2 times the rate, divide by number of employees. 14 plus 10 plus 2. This we call a weighted mean. This example question, and the information about 5 stocks, stock A, B, C, D, share price, or number of shares. What's the weighted mean of stock price? Found your answer to the nearest hundred. Sum of Wx divided by sum of W, weighted. And then 5 shares times 200 plus 7 times 120 plus 10 times 100 plus 12 times 80. What's the total here? Divided by على sum of shares, number of shares. How many shares I have? 650 shares. Okay, multiply 5 and add this one together. This one is written 12 times 80. Here is written 6. There is something wrong. I think this is wrong. This should be 6. Anyway, you need multiply each weight time by value and add it together. Divide sum of weights. This is the weight. وهذا الفاليو اللي عندي. Share price. Share price is the value, is number of shares. Take this average. تحسب weighted mean. Another example of weighted mean. I have 200 hospital employees. 50. Okay, nurses helpers $8. 50 are nurses helper and the 50 nurses helper. Nurses helper receive $8 plus 50 are practice nurses. What's the rate of practice? Practice nurse is $15 plus third one, 100 registered nurses. What's the rate of registered nurses? Is 24 hours times 24 hours. Divide by number of employers, 200 employees. Of course, if you want to calculate, you have to multiply 50 times 8 is 400 plus 50 times 15. Write it down plus divide by 200. Then we add this together and divide by 200 to get 17.75. This is the weighted mean measures. Dispersion measures. There are so many dispersion measures, but we will cover just the most important. First, take the range. Range is the simplest variation measure, dispersion measure, which is maximum value minus minimum value. If you remember, in calculating frequency table, we found the range, which is maximum minus minimum. Maximum minus minimum, this is the range. What's the major characteristic of the range? Only two values. It's affected by extreme value. It's easy to compute and return. This is the range. Difference between maximum minus minimum. Let's talk about variance. This is the variance. We'll talk about variance and standard deviation. Let's take example. How to find the variance. This example, which we calculate, I need to find the variance for this set of data. I have this data. I want to find the variance. There's a formula. There is a rule to find the variance. The variance is sum of each value minus x bar whole square divided by n minus 1. Of course, n minus 1 if it is a sample, and divide by n if it is a population. This is sample because given this is given in a given it is this is a sample. عينة sample. So I need to find sum of xi minus x bar all square divided by n minus 1. What is x bar? I already calculate x bar here. It is 7. So this is x. This first column taken from the data. Okay, that's first column. What is, I need x, each value minus x bar first, then I will make it square. So with x minus x bar first, then I will square it. Here is x is 5. 5 minus 7 becomes minus 2. Okay, 5 minus 7 is minus 2. So it's minus 2. 5 minus 7 minus 2 minus 2. 5. Then 6. 6 minus 7 minus 1 minus 1. 7 minus 7 is 0. 8 minus 7 is 1, 2. 12 minus 7 is 5. This difference between each value minus x bar. If I add these together, لو جمعنا هذه كلها مع بعض, I will get, of course, will become 0. This is one of x bar, one of mean properties, that the sum of deviations from x bar equal to 0. Is sum of x bar equal to 0. But actually what I need is sum of xi minus x bar. I need xi minus x bar all square. I need square. So I need to square this value. X bar all square minus 2 square becomes 4. Minus 2 becomes 4. 4. 1, 1, 0, 1, 2. 2 becomes 4. 5 becomes 25. This total, what I'm looking for the sum of xi مجموع total sum xi minus x by all square. This 44 divided by n minus 1. N is 9. 9 minus 1 is 8. 44 divided by 8 is 5. 5.5. So the variance is 5.5, which is s square, because it's for a sample. لو كان للمجتمع, it's for a population, we call it sigma square. Is s square because it's for a sample, just name. It is for a population, it will be, it's called sigma square, and it will be equal sum of each value minus x bar all square divided by n. Divided by n. Or if it is population, this will be mu. Actually, it is mu. Just the annotation. Here divide by n if it is population. If it is sample, we divide by n minus 1. Again, this question, find the sample variance for this data. Here, this is sample data. xi minus x bar all square and divide by n minus 1. Same. Okay, sample mean of a group data. Okay, what's a group data? Frequency table, if you remember frequency table, last chapter, frequency table, قفل المايك please. Frequency table of last chapter, how to find the variance and standard deviation for frequency table. How to find the variance for frequency table. This table, if you remember this table, this profit and this frequency, this is the table. I gave you this table, and I ask you to find the variance. Okay. In our example, which like this example, we found x minus x bar, x minus x bar, and x minus x bar all square. But here, no, it's different story. Okay, there is no x here. Here is I have interval. To find what is equivalent to x, and to say it is x, I need to find them center of this interval, or we call midpoint of this interval. I said before about midpoint. 600 minus 600 plus 200 divided by 2 is 400. So this is the 400. This is the midpoint. Okay. 600 minus 600 plus 1000 divided by 2, which is 800. For each time I can add class interval, which is 400. I can add 400. 800 plus 400, 1200, 600. Each time I add 400 because this is the class interval. So this is the midpoint, or what we call x. Instead of x, we're using midpoint. So this I will not need it. I don't need it no more. This part. Just I'm working on midpoint and frequency. Frequency and midpoint. Okay. Now we know why we found midpoint, because this needed to calculate it. Then I multiply frequency by midpoint. 8 times 400. Just look here. Here is notation denoted by f, frequency, and midpoint denoted by m. Now here I need to multiply f times m, 8 times 400, 3,200. 3,200. 11 times 800, 8,000. Okay. This f times m. Why I do this? I needed to find x bar. Now I'm working on finding x bar. There is x bar equal sum of f into xi, f in a multiplied by m, which is midpoint, divided by sum of frequencies. This sum of f times m, this value. So this equal 200 divided by 180 total to find x bar, because I want x bar in my calculation. To find x bar. Here is to find x bar. Come to x bar here. If I divide 33200 divided by 180 comes 1851. So then, x bar equal 1851.1 exactly. This x bar. Okay, now this column I use it to find x bar. I don't need it no more. محتاج بعد كده. Okay, now I need to find m minus x bar, all square. So this is m minus x bar. X bar is 1851, and 400 minus 1851 becomes minus 1451. This one m minus x bar. Okay, I'll do the same for all classes. Here's m minus x bar all square. This is all square. I need it squared. So this is m minus x bar all squared. Okay, it's all squared. Then I need to multiply this square value times frequency. This value times f times 8 becomes 16 million. There's f into m minus x bar all square. And so on. Another multiply this one times frequency, this one times frequency. This total becomes this numerator, upper, divided by 180 minus 1 and minus 1. Here is S. S is the standard deviation. S is standard deviation. S square, which we call the variance. If a question comes to find the variance, you need to find S square. That's all. No need for square root. If asked for standard deviation, which is S, we need to calculate it, find the square root of all this answer. Becomes 652.33. Okay. هذا مثال, this example, same as we did. I give you this one and find class midpoint. ممكن تقرأوا هذا المثال هذا.